This is some work that we're doing with Emory University, and we are studying the prevalence and screening and care processes of diabetes. A few quick statistics. There are about 30 million adults in the United States that have diabetes. Of those, 24% are not diagnosed. So screening is a real issue. How do you get people screened so that they can get the care that they need for their condition? In addition, there are about 84 million people at risk of diabetes through a condition known as prediabetes. That is when you go to your doctor, he does a test on you for blood sugar A1C, and you are told that you need to eat less, eat better, and exercise more. So some of you may have experienced that. So these are pretty big numbers, and what we are doing is studying the screening process and care process. If we can do a better job screening and get more people diagnosed, that's good. So that's the first part of our project, and that's what we'll be looking at today in our demo. Various Agile strategies to get people screened so that they get the care they need. And the second part of what we will be looking at as future work is once you have all these diagnosed people coming into the system, how do you redesign your care processes so that you can accommodate them?
Hi, I apologize for my voice. I'm glad that we have a microphone. Our project is called Designing Cancer Care for Kids by Kids. And as we heard this morning about the importance of cancer care, we look at how do we improve the experience within the clinic. And to do that, we go to the kids themselves to tell us how to improve their experience. And so from the very beginning, right now we've developed an app that's called a Passport app. And the idea is that the kids are going to be able to carry the app around with them throughout their journey to tell us about the times, how long does everything take, how long are they waiting, but also how do they feel in each location. So from a pilot study, we know that they spend the most time waiting in the areas where they're also the least happy. And so from that, we're able to figure out how can we reduce inefficiencies in the clinics and how can we improve the experience for when they are waiting. So the app includes different games and activities that can keep the kids engaged while they're in the clinic. So this is especially important when we're looking at other care models, for example, Proton Therapy Center, where the majority of kids are sedated. So what can we do within that environment to help to reduce their anxiety? And we can guess what might do it, but the only way that we can really understand how are we going to make these kids feel more relaxed, what do the parents actually need, is to go to the source. And so that's really the premise of what we're doing is how do you communicate with patients and their families to really understand how to improve their care and to give them the best experience possible.
Hi, my name is Katelyn Fry.
Rabeya, Jamshad.
And we're with the Humans Lab here at Georgia Tech under the advisement of Dr. Howard, who could not be here today, but she's still super excited about this opportunity. So our research aims to develop a system for the early detection of motor development disorders through the observation of infant kicking. Additionally, we aim to provide a platform for in-home therapy intervention for these children. Our system consists of 3 components: an infant sensor suit, a data collection app, and a mobile system. For the infant sensor suit, a series of IMUs are attached to the lower limb segments, and our data collection app captures infant kicking data from these sensors over extended periods of time. With this data, we can do lots of cool things, the simplest of which is determine periods of interest. For example, when's the baby actually kicking? Because it'd be nice to be able to determine that through a computer and not have to look at the baby. And that really helps to sort through all the massive amounts of data we can collect with this system. Additionally, we can calculate numerous kinematic features to determine what typical kicking looks like at various stages of development. So that way we can take an at-risk infant's data and thereby see if they are developmentally delayed or developing abnormally.
So the third component of the project is the Crib Mobile, and it is designed to to verify if we can use certain stimuli with a goal and reward-based mechanism and use these stimuli to modify infant kicking behavior or not. So we've integrated 3 stimuli, which are visual, audio, and movement stimuli, and the purpose is to introduce the stimuli at the infant's home. And then we're studying the infant's kicking behavior through 3 kinematics, which are kicking frequency, the duration of kicking, and the frequency of bilateral and unilateral kicking. We compare these kinematics with respect to the individual baseline of each stimulus and see what effect these stimuli are having on infants' kicking behavior. And for more details on how we're accomplishing that, you should check out our demo.
Yeah. Yes, that's what we're looking for.
Good afternoon, everyone. My name is Shawn Reginauld. I'm a student at Tech. And our project focuses on the realms of valvular disease and cardiology. And so interventional cardiologists typically perform a procedure known as TAVR, transcatheter aortic valve replacement. And it's a minimally invasive procedure used to replace the diseased aortic valve in cases of aortic stenosis and calcification, which obstructs the overall blood flow, which over time can cause mortality. And so one complication of this procedure, it's a fairly easy procedure, but for patients that have a lot of comorbidities like hypertension, ESRD, end-stage renal disease, and other complications and factors, it makes this procedure highly complicated. And so there's this phenomenon known as paravalvular leak, where a physician will misdiagnose the actual bioprosthetic valve that they put into these patients, which causes paravalvular leak, causing overall hemodynamics to change within the heart and can overall exacerbate over time. And so what we've done with Dr. Zhang is we've created a physiological ex vivo model that we do in-house, where we take physician-derived CT data, the contrast data. We take that, we create a 3D model using deep learning to kind of enhance the overall model from other patients and whatnot, to create a more personalized approach to this aortic valve strategy. By having this ex vivo model, we can then do in vivo testing from that, and then we can, ideally in a sense, create a more personalized strategy where we can appropriately size the aortic annulus, aortic valve, and in a sense, reduce complications further on.
Hello, I'm Maribeth Gandy. I'm a principal research scientist within IPAT, and I lead the Human Tech Frontier Research Initiative there. I'm also the director of a center within IPAT that's really the hub of translational research for the IRI. So our job is to try to push the fundamental research from the lab out into the outside world. And so a lot of our key expertise is in IoT, machine learning, wearable technology, AR and VR, and HCI techniques for design and evaluation. So we have so many demos, I had to write it all down on a piece of paper, because really our role is to be, be this hub of convergence research on campus. So we apply all that expertise I just listed to domains like healthcare, successful aging, assistive technology, smart cities, and the future of work, which is really an emerging area for us right now. So the things that you will see today from my group are funded by, we have a couple of rehabilitation engineering research centers that we're associated with, NIH, we partner with CDC, Emory Healthcare, and many others. We also have a lot of, unlike maybe what you would expect at a university, we have a lot of our work funded by industry, both very large companies and startups. So just to highlight some of the demos that you can see, my colleague, Brian Jones, who is also the director of the Aware Home, has a whole portfolio of projects that related to successful aging and supporting people with mild cognitive impairment. So this includes novel techniques for gait tracking, a smart bathroom that can adapt to people with disabilities or people as they're aging, ambient alerting techniques. So ultimately, they're kind of cognitive prosthetics to support people in the home. We've invented some new wearable input and output devices centered around smart textiles that can sense touch, and the use of active tactile display. And in particular, we've been looking at applying that to applications for people with vision impairment. We also, kind of an offshoot of that work, we've created a knowledge base around, called body maps, that the idea is that practitioners and designers and people within healthcare can use this to help them design their own wearable technology products. And lastly, a project that I'm really closely associated with, we're using augmented reality training in collaboration with folks at Emory in the highly infectious disease unit, and figuring out how can we use these immersive technologies to help train personnel that work in these like very stressful, very mission critical environments. You can also pop up to the third floor and see a whole portfolio of IoT sensing ML work from some of my other colleagues. So hopefully you're now intrigued and you will come and see all these great demos. Thanks.